All right, ladies and gentlemen, let's take a look at lesson 5.3A. We're going to take a look at this first round of simplifying radicals. And actually, a lot of what we're going to see here in this beginning part is going to be more of a review of what was going on there than what we actually see in the book. So we want to be able to review some of this, and actually through a couple of our warm-ups we already have. What we want to keep in mind in order to be in simplest radical form, we have a few criteria we have to reach. There's no decimals, so that's why your calculators aren't going to be an option here. There cannot be any pairs of factors, which means you can't have a perfect square. What that means is I can't have the square root of 8 under there, because 8 is 4 times 2, or there we have that perfect square. Or if we were to keep breaking it down, here is a pair of 2. So we can't find a pair of factors or a perfect square underneath the radical. There can only be one radical in the answer, and we'll see that as we move through our operations. No fractions in the radical, and then no radical in the denominator of a fraction. So let's take a look at how those rules apply to this first lesson. So we have the square root of 45 that we're going to simplify first. What we could do is go through and look for perfect square factors, and I do like that option. If we think about what our perfect squares are, 1 times 1 is 1, which is not going to be useful for us in this case, but that's our first perfect square. The next is 4, because 2 times 2 is 4. Then we have 9, 16, 25, 36. 49 is 7 times 7. So I'm just going through these. My mental math is pretty strong. My math facts are really strong, so I'm just able to rattle these off. But after 49, if you need to, you would do 8 times 8 is 64. 9 times 9 is 81. Then we have 100 for 10 times 10. We do like to recognize 11 times 11 as 121, and usually the last one we ask you to see is, or to recognize, is 12 times 12 is 144, okay? So when we look through here, I'm looking for one of my perfect squares that would divide into 45. Obviously, everything greater than 45 won't work, so we're just looking at this last row, and 9 is a factor that perfect square that divides in there. 9 times 5 is 45. What I like about that is 5 is prime, which means it can't break down at all. Now what I can do is take the square root of 9, and the square root of 9 is 3. So I have 3 square root of 5. So that's one way of doing this problem. All right? So that's one way, taking the square roots of those perfect squares. The other way to do that is to simply break these factors down. So we have 9 times 5. 5 doesn't break down any farther. So because it's not a perfect square, we know we're done there. And 9 times 9 is, or 9 is 3 times 3. This is that pair of factors that we talked about. And so remember on the first screen, it said there can be no pairs of factors underneath the square root. So that means if you find a pair of factors, they need to come out of the radical. So the 3 is going to come out. 5 doesn't have anything to pair up, so there's 3 square root of 5. So either way, looking for a perfect square or looking for pairs of factors is going to work for us. So let's take a look at 72. I need to find something that divides into 72. I'm not sure how strong many of you are with your math facts, but because it ends in a 2, I know that 2 divides in there. And sometimes that simple division gets you down to a number that you do know how it breaks up. When I look at 2, 2 is prime. It's not going to break down any farther, so I underline that because I know I need to make sure 2 somehow is included in my final answer, whether it gets paired up with a factor or not. Because we're looking for pairs of factors, like I just mentioned, we can divide out another 2 from 36. So now I have a pair of factors, and I'm going to circle that. So what that means is a 2 is going to come outside of the radical. Then I have 2 times 9. Underline the 2 so you don't lose it in this long factor tree. And then 9 we already did was 3 times 3, so here's a second pair of factors. So 3 has to come out. So when we look at what happened here, we had a pair of factors that gave us a 2 outside of our radical. We had a pair of 3's that gives us a 3 outside of our radical. And then the branch of our factor tree that didn't get paired up was a 2, and so that stays under the radical. Notice I put multiplication there because that's the entire relationship underneath a factor tree is multiplication. So whether the factors come out or whether the factors stay in, we're going to multiply those together. So we get 6 square root of 2. We talked about this during a warm-up that you can check these answers by simply simplifying them on your calculator. So type in square root of 72. See what decimal equivalent that gives you. Type in 6 square root of 2 and see the decimal equivalent there. So if we were to look at that on those, and I'll get the calculator started there, and we'll take a look at that just to show you guys what we mean by that. So we'll wait for this to warm up. If we take a look at square root of 84, once again we can break that down. This is 2 times 42. We can do that again and do 2 times, and this would give me 21. So here's a pair of 2's. 21 is 7 times 3. These are both prime, so we know they don't break down any farther. So if we look here, 2 is going to come outside of the radical. But this time, the pairs of factors I have are underneath, or I'm sorry, the 2 factors I have are left underneath the radical, and so we're still going to multiply those together for 2 square root of 21. All right, now I did mention that we would take a look at what it looks like to check some of these answers. So let's do that. If we take a look at the first one, we said square root of 45 is what we were given. And then we said our answer is 3 times, you don't need to put the multiplication in there, square root of 5. And those give us the decimal equivalent. If we take a look at 2, we had the square root of 72. What syntax there did I have? Oh, I had 2. Square root of 72, and gives us 8.48. I'm not hitting clear here. I want to keep my entire decimal value on there. If we take a look, as we scroll through here, we said our answer was 6 square root of 2. So we'll type in 6 square root of 2. And we get the exact same decimal equivalent. And for the last one, we had the square root of 84. And then we had 2 square root of 21 as our answer. And we get the same decimal equivalent. So at any point, if you're not sure, well, is this what's coming out? Is this what's staying under? Try it both ways and see which ones give you the decimal equivalent. All right, let's take a look at our next set of examples. Here's what we have as multiplication. And so what we know is that if we have 2 radicals being multiplied together, regardless of what's underneath the radical, we can multiply those. So just like I can do x times x squared, I can do 3 times x, what's underneath the radical doesn't matter. So I can take this and write it as 5 times 15 underneath the radical. We can combine it into one radical. What that allows me to do is to start breaking things down. So 5 doesn't break down, so I'm going to underline that so I don't lose track of it. But 15 I know is 5 times 3. Both of those are prime, so I know I'm done, and I can start looking for my pair of factors. The pairs come out. So 5 is going to be underneath, or going to be outside the radical. 3 is going to be under the radical. So what is that going to look like as far as checking an answer? Well, we're going to go back to the calculator. And we're going to type in square root of 5. And I'm going to have to close my parentheses. If you notice, my 5 isn't underneath a radical, like some of you have that. Mine brings up a parenthesis. So I've got to close the parenthesis. What that does is it closes that radical. That means that's the only thing I'm taking the square root of is 5. Then I'm going to multiply square root of 15. And I'm going to get, once again, a decimal equivalent. Then I'm going to take my simplified radical of 5 square root of 3, and notice that I get the same radical, or same decimal equivalent for that radical. And so we're going to still be able to check our answers the same way. We just have to keep in mind that we can't put the 5 and 15 under the same radical at the beginning of our calculations on the calculator. All right, when we look here, it's going to be the same thing. Multiply, multiply, I get 6. This is square root of 8 times 10. So let's figure out how we want to simplify these things. I like 4 times 2 for 8. And 4 is 2 times 2. So I've got my pair of factors. 10 is 2 times 5. Even though they are separate from each other, guys, this was multiplication, so it's still multiplication there. And so I can put those together as a pair of factors. So 2 is coming out. I've got a 2 coming out. So let's take a look at what we have outside here. We've got a 6. We've got a 2 from the pair of 2's, and we have a second 2 from the pair of 2's. So we have all of that outside of our radical. The only thing left in here that has been underlined is 5. So that means I have square root of 5. Now we saw this earlier with example 2. We need to multiply those together. So we get 24 square root of 5. And so once again, we can go back to that calculator. And we can type 2 square roots of 8. Just close your radical or arrow out. Times 3 square roots of 10. Hit enter. And then I'm going to type in 24 square roots of 5. We get the exact same decimal equivalent, so we feel really confident that we have the correct answer. All right, ladies and gentlemen, I'm hoping we feel pretty confident. I'm hoping this shows a lot of review from what we did in Algebra 1. And have a good evening.